Good evening, everyone, and welcome to Everything Matters, Tales from the Periodic Table. Tonight, we are doing nickel. Nickel is a really interesting element. I'm kind of excited about this particular night. We've had other nights that have been not as easy to do, like scandium, but nickel is really easy. I'm your host, Ron Hipschman, and our talk here is going to be divided into two parts. So I'm gonna tell you a little bit about nickel and its history and some of the things that can be done with nickel, and then we're gonna have Chuck Mignacco here to talk about nickel plating. We're actually gonna do some nickel plating for you, so it's gonna be kind of exciting. So how many people have been to After Dark? Oh, how many people are new to After Dark? Oh, okay, that's actually about half and half. I hope everybody here has gotten their nickel collectible card. We produce one of these every time, so if you come for the next 118 weeks, or minus 28, you will have the entire periodic table. It will be quite a collection to have. And if you've missed any, you can pick up some of the previous cards over on our table over there, so you can still fill in your collection. Specifically also, for those of you who were here last month when we didn't have our card for cobalt yet because the printer didn't deliver them on time, we hope that you'll go and pick up your cobalt card. Looks like this. Nope, that's nickel. Looks like that. Blue, of course, because cobalt is responsible for many of the blue colors. So, by the way, if you do enjoy After Dark, you know we have a special membership for After Dark. It's about, I think it's $45 a year, and you get to come to all 52 After Darks a year. That's a pretty good deal. So by all means, become an After Dark member. So, nickel. Nickel is on the periodic table. It's in that first long row there. It's about right there. Nickel is element number 28, that's its atomic number. That atomic number is specifically how many protons are in the nucleus of the atom. So there's 28 protons inside the nickel nucleus. That's hard to say. And that means there's also 28 electrons surrounding that nucleus. But there's differing numbers of neutrons, and we'll talk about that in just a bit. The first person to refine nickel was Axel Kronstedt, and he did that in 1751. He was actually kind of a mining expert with the Bureau of Mines in Sweden, and he had this element, well, he had this metal that was called kupfernickel. It was kind of it wasn't an element, but there were several. They knew there were several things in it, and he was able to actually separate the Kupfer, which is next month's element, copper, from the other small impurity in there, which he called nickel. So that's where we get the nickel from, is the combination of the copper and nickel that he refined. And that was in 1751. He's actually known as one of the founders of modern mineralogy, so he's actually kind of an interesting guy. We get nickel from several different ores nowadays. One of them is, I like kind of the name of this one, nickeliferous limonite. And that's actually just nickel and iron mixed together and oxidized, so it's rusty nickel and iron, really. Another kind of beautiful one. Nickel is responsible for some really nice colors. Garnierite, which is a silicate. It's hydrous nickel. And another one here is pyrrhotite and pyrrhotite, actually. It occurs, it's kind of a conglomerate mineral there. You can see there's pointers to magnetite, which is an iron oxide. If you've played with the black sand exhibit, you've played with magnetite. That's the sand you can collect with a magnet on the beach. It's also, if it's in a large format, a stone, that's also known as lodestone. It's the only stone that's actually magnetic in and of itself. You can pick up paper clips and things with it. One of the first sources of nickel, and probably iron as well, was meteorites. Meteorites are pieces of stone that come from the solar system. And here's a slice of one. This is a nickel iron meteorite. There are both stony meteorites and there are these metallic ones. These ones are found more often, but they're not the most common. But they're found more often because when you kick them, it's a big chunk of metal and they're noticeable. Whereas if it's just a stone laying on the ground, you don't really notice it. So these meteorites, nickel iron meteorites, are the most common ones. And you can tell that they're from space and that they're meteorites because of the crystal structure of the metal. If you etch it with acid, it's not real obvious right here. You can see there's this crisscross pattern of crystals inside the metal. This was a piece, by the way, from the collection of the California Academy of Sciences that they allowed me to borrow and scan. So they have a really nice collection, and I thank them for allowing me to borrow these things. They have a really wonderful collection of meteorites over there. Here's another slice it's been cut. It didn't fall as a cube. It's been cut into a square, and you can see here these patterns of crystals. They're called Widmanstätten figures, or patterns. And so this is how you tell it's a meteorite. The ones that aren't meteorites, they typically are, you can also call them meteor-wrongs, but anyway. A very large meteorite, one of the sources of where we get nickel on the Earth here, a very large meteorite fell in northern Canada near the town of Sudbury, just above the Great Lakes there. It's a nice little town, it's a nice little town except for the giant mine that sits outside the town, but actually it's a really interesting mine too. You can go there and they'll give you a tour of the mine, so it's a really kind of a cool place to go. But that meteorite struck here. It doesn't take a huge meteorite. You mean a meteorite the size of a house is going to provide you with tons and tons and tons of iron and nickel, and this was probably a little bit bigger than that. By the way, right near here, I don't know if you saw, there was a lake next to the mine here, but right next to the mine, there's this really cool building. You see it there? It's shaped like a snowflake. That's one of our sister institutions, Science North. So if you're ever in Sudbury, go to Science North. Really nice museum. Highly recommended. So, nickel is produced in many places besides Canada. Canada produces about 11% of the nickel in the world, and you can see it's pretty distributed around the world. Russia produces a lot of it, 15%, in the Philippines 13%, and so on. So it's a pretty well distributed source of metal. It's used for a lot of things. So if we look at, this is nickel production, if we look at nickel consumption, it's only used for really, a few things here. Mainly stainless steel. A little bit for other alloys, some of which I'm going to show you tonight because they're really cool alloys. And then electroplating is another large user of nickel. We use more and more nickel every year. As a matter of fact, we look at the production over time. It's kind of a disturbing graph. It's kind of growing exponentially. And it is a limited resource, which means that we're not going to be able to continue to do this. So we better get pretty good at recycling it. It occurs naturally, of course. It's the 13th most abundant element in the universe. I see it right up there. And if we move in a little bit, we're going to move into the sun. It's the 11th most abundant element in the sun. And now, if you go to meteorites, of course, since many meteorites are nickel iron meteorites, it's the 8th most abundant in meteorites. Again, you have to take into account those stony ones, which are silicates and other elements. The 22nd most abundant element in the earth, of the crust of the earth. However, that's just the crust. If you go down to the center of the earth, the core of the earth is made out of this nickel iron alloy as well. So there's a giant slug of it down there. It's just inaccessible to us. And there's not much is actually in the crust. It has sunk to the middle of the earth. In the oceans, it's pretty rare. It's only the 29th most abundant element in the ocean. And if you look at us, it's the 30th out of 41 elements in your body. And we're actually not quite sure about that, why it's there at all. So it's made inside of exploding stars. So that gives you a clue about where we came from. We are the product, you and I are the product of exploding stars. It's like Carl Sagan used to say, we are star stuff. And since the sun has a good amount of nickel in it, and so does the Earth, that means that we are all made from that those past exploding stars. So we're kind of a second or third generation star, the sun is. Now I mentioned that there's 28 protons in the nucleus, and I said there's different numbers of and there's different numbers of neutrons in the nucleus. When there's different numbers of neutrons but the same number of protons, so it's nickel, we call those isotopes. Isotopes. Iso meaning the same and topes meaning place. It's the same place in the periodic table. There's lots of them here. That number that you see on the top there, the 48 to 78, that's if you add all the protons and neutrons in the nucleus. That's sort of its atomic weight. So you can have as few as 20 neutrons in the nucleus. 20 plus 28 protons gives you 48, and then up to 78, which means there's 50 neutrons and 28 protons in the nucleus. Now these are not all, you can't hold all of these. They're not all naturally occurring. As a matter of fact, there's only a few of them that are actually stable, that are not radioactive. As a matter of fact, there's only 5 of them that are not radioactive. Nickel 58, 60, 61, 62, and 64. Those are the only stable isotopes of nickel. So they come in different proportions in the Earth's crust. Nickel 58 is by far the most common of nickels. So if you pick up a chunk of nickel like this, 68% of that is nickel 58. And going down, 26% nickel 60, and so on. 3% nickel 62. So nickel, this is the kind of the natural distribution of nickel. Now, there are all those radioactive ones too. Some of them are sort of long-lived. If you look at the radioactive ones, these are the longest lived of the radioactives. So nickel 56, 57, 59, 63, 65, and 66. The longest one there is nickel 59. Its half-life is 76,000 years. So that means if I have a chunk of nickel 59, which I do not, because it's radioactive, half of it will be gone in 76,000 years, and in another 76,000 years, half of that will be gone, so I'll have a quarter of it left, and so on and so on. So if we look at nickel, here's what nickel looks like. Actually, I have some here. I can pass this around. If you have a nickel allergy, do not touch this. It's rare, but nickel, feel how hefty it is. Nickel's pretty, it's got a good heft to it. It's denser than iron. As a matter of fact, its density is 8.9 grams per cubic centimeter. How does that compare? I know. How does that compare? Well, what's water? Anyone know what water is? 1 gram per cubic centimeter. And we can compare it to a few other things here. Gasoline is less than water. That's why it floats on the surface of water. But some of the lighter elements, sodium, also floats in water. And down to the most dense element, osmium, which is 22 grams per cubic centimeter. That's really dense. And I have some cubes up here that I invite you to come up and try later on. If we look at the density, here's a density diagram with the densest elements over on the left-hand side and the least dense, all the gases, over on the right-hand side here. And the ones I have down here, besides, most of them are elements, but the first two I wanted some really light things. So I have maple, which I called Ma, and plastic, which I called PL, because those aren't elements. Those are really low density, but then we have very high density stuff. We have tungsten, we have lead, we have copper, we have iron, we have titanium, we have aluminum, we have magnesium, and then plastic and maple. So come up and try hefting those things. The tungsten, by the way, has almost exactly the same density as gold. So if you want to know what a gold brick would feel like if you had to lift it, a gold brick that size would weigh about the same as that tungsten brick. Be careful. Use 2 hands. It's extremely dense. If you drop it on your foot, it will leave a mark. So nickel is not a super hard material. If you use the Mohs scale of hardness, where talc, which is very easy to scratch, is 1, and diamond is 10, nickel falls right there at about 4. So you could scratch nickel with steel and glass and things like that. So it's not a super hard element. It's not the cheapest element either, but it's not super expensive. About $6.40 a pound right now. So it's not super expensive. The thing I'm handing around to you, there's not a lot of value there. It has a kind of a medium-size atom. If you compare it to hydrogen, it's a little bit bigger than hydrogen. It's about 3 times the size of a hydrogen atom. That's because it has electrons hanging out there. As a matter of fact, if we look at this, I kind of like this chart. I used it first last month, and I really like this chart, so I'm going to use it again. If we look at this chart, this is sort of starting at hydrogen on the left and going to uranium on the right. You can see the densities change. They kind of peak, and they have peaks and valleys as you get to the heavier and heavier elements. Hydrogen, so way over on the left there. It's not the biggest. It's not the biggest. It's not the smallest element. Helium is the smallest atom, but our element for this month is right there. It's kind of a medium density element. You notice that the peaks on the very top, which are the largest atoms, those are the atoms that have 1 electron hanging out there, and that electron just kind of gets farther out there. Those are all the alkali metals that you find over on the left-hand side of the chart: sodium, potassium, lithium, rubidium, cesium. And the ones at the low end there, the smallest atoms are the noble gases, because they hold on to their atoms really close. They're the ones over on the right-hand side of the chart. So those are helium, argon, krypton, neon, xenon, radon. So this is the periodic table of the spectra. And so nickel has kind of it's a moderately interesting spectrum. It has some bright lines in it. It's makes it easier to identify if you stick it in a flame, or if you can vaporize it somehow and put electricity through it. You can actually see it in the spectrum of the sun. If you look at the sun, its spectrum sort of looks like this. I couldn't stretch it out all the way, so this is like a whole bunch of spectrums piled one on top of the other with violet at the bottom and red at the top. But you would normally string this all into one line. Some of them are labeled there. Some of those dark lines are labeled. When you look at the sun, you see a continuous spectrum, all the colors, but there's a few missing. There's dark lines across the face of the solar spectrum, and those dark lines are elements in the outer atmosphere of the sun that are absorbing light. And they absorb light at specific frequencies, specific colors as well. And nickel has some fairly prominent lines in the yellow to violet side of the spectrum, and that nickel does exist in the sun. You can tell it's there. So what do we use nickel for? Well, most of the nickel, as we saw on that previous slide, is used in stainless steel. It forms a fair amount of the steel. You have to add quite a bit of nickel in there. I have a table here that kind of shows stainless steel alloys. There's lots of different stainless steels. The most common ones is the steel it's an alloy called 304, and then the other one that's really popular is 316. That's most of what you find in shops, and those two have, the green column tells you the percentage of nickel. So 304 has 8 to 10%, and 316 has 10 to 14. But if you look at all the alloys of nickel, you'll find that there's either 0 to 37%. So the ones that have 0 have other elements that make it stainless, like chromium and manganese and things like that. So there's a lot of really interesting alloys of nickel, and so I wanted to do some of those. And so just to prepare for that, I'm going to heat up some water here. So I'm going to go to my microwave here, and I'm going to heat this water up right here. Give it 3 minutes. So I'm going to show you an alloy of nickel that's actually very interesting. The first one is called Invar, and this is a really important alloy of nickel. It's iron. It's 64% iron and the rest nickel. And this alloy, which I have a piece of right here, this is Invar, is made so that it does not expand and contract with temperature. That is kind of a unique kind of thing. Most things get longer when they get hotter and shorter when they get cooler. And that's not a good thing to build, for instance, telescopes out of, because you don't want your parts getting longer and shorter when the telescope gets hot and cold, which it does, because sometimes observatories in the desert, very hot during the day, and at night it gets very, very cold. So you build the structure of the telescope, the mirror holders and the structure of the telescope out of this Invar material. And I have some factoids written down here that I didn't want to miss. It was invented in 1896, and he actually received the Nobel Prize in Physics in 1920 for that discovery. So that's a Nobel Prize winning metal right there. It was also used in Paris at the Bureau of Standards in Paris. They needed to make meter bars that were 1 meter long that they could send around, and people could calibrate their meters. They don't do that anymore. There's very few physical standards anymore, but you had to make it out of something that didn't get longer or shorter when it got hotter and cooler. So Invar was a really good choice. So again, 30% nickel, 36% nickel, and 64% iron. The next really interesting alloy is nichrome. Nichrome is what the heating elements are made out of. They have a fairly high resistance to the passage of electricity. So when you plug them into 120 volts, this heater, for instance, provides some resistance to the flow of electricity, and that turns the flow of electricity into heat. And so, but the interesting thing is, because it's a alloy of chromium, nichrome, and nickel, it doesn't corrode. And so you can make this thing hot and cold for years and years and years. And you do in your toaster and in your hot plates and things like that. And this stays nice and shiny. Well, it might get a little bit of corroded on the outside. So that's also another really interesting alloy. Again, because it doesn't corrode. This was patented in 1905, by the way. It's the oldest documented form of resistance heating alloy, nichrome. It's 80% nickel, 20% chromium. And there's lots of other combinations for different kinds of applications. So one more, check my water over here. Am I done? Am I hot? I could use another 2 minutes. Another cool alloy is, and I like the name of this one, is MuMetal. MuMetal is a nickel iron, kind of a soft alloy, but it has what's known as a high permeability. It can shield magnetic fields. So if you put a magnet on both sides of this thing, they don't feel each other. And this is used in a lot of different applications. For instance, most oscilloscopes have a shield around them to keep outside magnetic fields from affecting where the beam is on the CRT. Also, if you have a transformer that's inside audio equipment, you don't want the magnetic field of the transformer affecting the other electronics in it, so you might stick the transformer into a can of MuMetal, and that would shield and keep the magnetic field of the transformer from getting out. So that's kind of a really interesting metal. Okay. The next one I do need the hot water for. And I'll use this camera because I'm going to show you some stuff. It's probably hot enough now. Let's just assume it's hot enough. Oh yeah. So I have some nice hot water here. The next alloy I want to talk about is one called Nitinol. Nitinol is memory. It's a shape memory alloy, and this here is Nitinol. You notice it's easy to bend. It kind of bends like solder. Sorry, I'm going to get back in the view there. It bends like solder, so I can kind of take it and wrap it around my fingers here, and I make a little coil, and it sort of stays there. If I heat this up, though, it will remember where it came from, what its shape was originally, which was a straight piece of wire, and it will unwrap. Let's see. I'm going to get the camera out here so you can see it too, because I'm going to drop it into this hot water right here. There we go. Okay, so there's the MuMetal. There's the Nitinol, and I'm going to drop it in there and watch what happens. You see that? Just, ow. It's actually stuck in there. I'll drop another one for you. So here we go. 1, 2, 3. You see that? It actually jumped out. It's really cool. Shape memory alloy. You can actually make some interesting things using that. For instance, this is a little ice bandsaw, and it has a piece of Nitinol wire around it, and I'm going to put some hot water in there. Oops, I'm stuck. There we go. Let's put some hot water in there. The hot water is going to allow it to come back to its original shape. Put this on here. So this is wrapping around a little brass wheel right here. And I'm going to put that in the hot water. And it might even run all by itself, but it'll run even better if I try to bandsaw a piece of ice. So let's see if I can do this. This worked at home really well. There we go. You can do it. There we go. You see that? I'll do it again. As long as there's a cold source, you can actually slice the ice up. That's kind of a use, well, not a real practical use of Nitinol, but it's a nice toy. Okay. Oh, by the way, I did take a video here just to show you of the Nitinol so you can actually see it. There, you see the metal unbending there? Another alloy is one we talked about last month, because it also includes cobalt, is alnico. You'll never guess what elements are in that. Let's try aluminum, let's try nickel, and cobalt. That element can actually be magnetized. These are alnico magnets, and they are easily magnetized, and you can make them into permanent magnets with north-south poles. By the way, that middle one there, that middle one is a cow magnet. Anyone know what a cow magnet is? Have you seen a cow magnet? Oh, there's a few people who know cow magnets. Excellent. Those are placed in the, let's bring a cow out here. There we go. They are placed in the first stomach of cows because cows eat staples and barbed wire and things like that, and you don't want that to go further through the digestive system because it causes something called hardware disease. It punctures their insides, and so you catch it in the first stomach with this cow magnet. Okay, we can let the cow go now. An interesting thing about magnetic materials is that different elements lose their magnetic abilities at different temperatures. And here's kind of a chart of that. You can see the top one there, which is cobalt, loses its magnetic properties at 1400 degrees Kelvin, and iron loses it at about 1,000 degrees, but nickel, right there, it loses its magnetic capabilities at only 631 degrees. So if you had them all lined up and you hit them with a torch, the first one to go will be nickel. If you had nickel attracted to a magnet. Speaking of nickel, we keep saying nickel. This is what we normally think of as nickels, right? This coin that has been issued by the US government for many, many years is made out of nickel. But it's not completely nickel. As a matter of fact, it's mostly made out of copper. As a matter of fact, it's 75% copper. It's only 25% nickel, which means that it's not really magnetic. Pure nickel is magnetic. I'll use this magnet right here. I got the bowl of nickel down here. So I'll bring it back up here so I'm in the light. And you can see here that nickel is magnetic. It's attracted by a magnet. Nickel balls. These nickels are not attracted by a magnet because they're only 25% nickel. This is another piece of beautiful nickel that came off of an electroplating machine. It's pure nickel. It's attracted by a magnet. However, there are some coins that are made out of nickel. No US coins are made out of nickel, but I did find some. So if you go and find some Canadian coins that are pre-2000, those coins are actually magnetic. So there are magnetic coins. You can't use a Canadian quarter in a US vending machine because there are magnets that stop them from going down into the vending machine because you don't want to, they're not worth as much as a quarter, so you don't want to accept a Canadian quarter. They're the same size. And also Canadian nickels, there's a Canadian nickel right there, are made out of nickel. And Canadian dimes are also made out of nickel. So do you call it it's not made out of dime, it's made out of nickel, so it's a dime made out of nickel. I don't know what that means. Anyway. Nickel is very important for battery technology. In the past, nickel-cadmium batteries, NiCads, were really popular as rechargeable batteries. And more recently, that has been replaced with a different nickel battery, the nickel metal hydride. Oops, it says halide. That's not what I wanted to say. Nickel metal hydride batteries. And those are kind of our current technology, as opposed, and lithium as well. But these are kind of, you've seen these in the store. Eneloops are also nickel metal hydride batteries. Spell checkers. Always check your spell checkers. Biologically, the role of nickel is not actually fully understood, so we really don't know why there's metal in the human body. However, it can affect the human body because nickel actually can cause a few individuals to break out in a rash. So that is a problem, so I hope that none of you get any rash from handling the nickel here. You probably would have known ahead of time if you were allergic to nickel. So now I'd like to invite Chuck. Chuck, come on up, and we're going to do a little, I'm going to read your introduction here because Chuck is our head of operations, our director of operations. Without him, this place does not run. He actually takes care of our bay water and heating system, our solar plant on the roof. He takes care of, well, basically everything, I think.
All the stuff that moves.
Anything that, and the stuff that doesn't move, too. I mean, sometimes me. So Chuck's going to talk about nickel plating. And we're actually going to do a little nickel plating demo here for you as well.
You want to start with warming it up?
Sure. Let's. Okay. We're going to put a solution here of nickel ammonium sulfate. So we're going to start with a bath. To that, we're going to add nickel ammonium sulfate. We're going to. It's already been dissolved. And it works better when it's a little warm. And so the plating happens faster. You want that to happen faster, don't you? That's why we have the microwave oven here.
Things moving around in the heat a little better. Okay.
Okay.
And, batteries right here, and these are right here. Okay, we are set.
Okay,
Let's
so
go.
the setup is what?
Yes, so we're going to be using DC batteries, size D batteries, and just doing a direct connection through, and we have a piece of nickel.
So there's
Right
the
here.
nickel. Put that
Yep.
in the
As soon
solution.
as we get the solution out of there. I, as a fabricator, metal fabricator, I use a lot of welding rods that have a lot of nickel in it. It makes pieces of metal that contract and expand fast in heat. It gives them durability, so they don't crack. The welds don't crack.
So it kind of does the same thing that the Invar kind of has that same effect on Invar.
yeah, it's just a really it's very durable. I think that's probably good enough for the.
Yeah, I don't think it has to be boiling or
I
anything.
won't stick my finger in it though to find out. All right. So we got the solution and we have the nickel.
We're going to put a penny in there as well.
And let me get us hooked up.
And then
here
we're going to hook it up with a
electrically.
battery. So we have a battery here. We're going to run a wire from the positive end of the battery to the nickel. This is not complicated. And we're going to run a wire from the negative end of the battery to, you'll never guess, yes, the penny. So we have a bunch of pennies in a jar there that I have cleaned up. I took some acetone. Acetone dissolves grease, and so I took my finger grease off all those pennies. And they're kind of bright, shiny new pennies, too, so we don't have to worry about that.
Okay.
So the penny gets hooked up to the negative, and the positive side gets hooked up to the nickel. And when that happens, the nickel metal comes off of the nickel plate into the solution and then over to the penny. So there it is, going over
And
the
you can
penny.
see it,
And what
you
that
can-
does is deposits on the penny, and the penny becomes nickel plated. Oh, I should bring the camera
So it
over there
makes
so we
it,
can see this. There we
gives
go.
it rust and makes it rust inhibited, and
So there we
you
have
can
the
see
penny on the end
you
of
can
the.
see the reaction on the nickel rod.
Yeah, you can see some bubbles forming there on the nickel. Since that's on the positive, that's probably oxygen.
And we're getting plating. Yep, we're good.
We're using just 2 D cells, so 3 volts. This is how easy it is to do at home.
Yep, it's gone from copper to starting to get the
It's getting kind of
the
silvery,
nickel
isn't
silver color. Yep. And we were at this earlier today, so we have some that have been done.
it? Believe it or not, we tested this before we showed it to you. Always good.
I'll let that sit for a second while I bring out. Here they are. This one was really corroded, so it's kind of half done. But I will hand those out.
Yeah, I should pass those around. You can see the.
Here you are.
I'll look at here, and I'll
There you are.
swish this around a little bit more. Take a look at it,
Here you are.
and that's getting pretty
Yeah.
silvery there.
Oh yeah, there it is. I think we've achieved the goal. Yeah, that looks great, actually. So I brought a spring as well. Just this is a beryllium copper spring,
Mm-hmm.
and I brought it to show that if you one of the other things that nickel is really good for is that when it coats something, it can move a lot. And so I was going to do the penny, and then I was going to drop that spring in. But here you go. That is me wash it off with a little. What do we got here?
There's some
what am I-
distilled water right here. You can just squirt it in there.
Yeah, that's true. All right, and there you go. And you can see the edge there where it's the little the electrode was touching where it didn't coat.
Oh, yeah.
And there's the other side. Perfect.
I can hand that one out, too.
There you are.
I'm going to try to plate that spring.
Yeah, I'm gonna plate the spring.
And if folks want to
So I
come
love
over
about-
after and plate some things, too, we can plate them.
I very much love working here when I have to walk into the shop and go, I need a spring made of copper for plating, and I asked it about 10 minutes before I got here, and we have a whole drawer for no good reason.
Whenever you need something at the Exploratorium, we have a email list. You can write on it, and within 10 minutes you have anything you ask for at the Exploratorium. It's really amazing.
I asked for a ring sizer once, and I have 4 of them on my desk, and no one told me where they came from, and they're still there. All right, I think we are becoming a nickel-coated spring.
And why would you coat it with nickel instead of something like chrome, which is pretty chemically
It
inert?
is much more flexible, and so you get where chrome would crack and break free and expose the underneath. This can move with the metal much better over a longer period of time.
Yeah, I've kind of noticed on chrome bumpers it kind of can flake off.
Exactly. Yes. So yeah, we were saying that when it takes the nickel is on this plate,
Right. That plate is made out of pure nickel.
and it combines in the solution with
The sulfur, the sulfate.
nickel sulfate, and then as it moves across to the fluid, it then eliminates the sulfate and then drops the nickel on the spring.
The negative electrode attracts the positive nickel. And so it plates out onto the copper itself.
And there we go.
Got a
We
nice
have
spring there.
Nickel-coated spring.
Very cool.
Not plated, not coated, plated.
Plated. Yeah,
Plated.
not painted. It's actually part of the metal itself.
All right. There you
Cool.
are. Alrighty. Want to do another one of these?
Sure, do another penny. Or we can
Okay.
have people come up and do a penny if they want after. I think we have enough pennies.
Alrighty.
So I'm going to leave you with a little haiku. We found this wonderful source online for elemental haikus. So for nickel, we have forged in fusion's fire, flung out from supernova, demoted to coins.